Right now. Somewhere in a factory in Taiwan. A machine is etching lines thinner than a human hair onto a piece of silicon the size of your fingernail. Those lines will become a chip. That chip will go into a phone, a car, a hospital. But that machine, it didn't build itself. Someone designed it. Someone who spent years learning how electricity moves, how circuits think, how energy becomes intelligence. That person is called an electrical engineer. And in the next 10 minutes, you're going to understand exactly what they do. And here's the thing nobody tells you: every light that's on right now, every signal your phone is receiving, every heartbeat being monitored in a hospital somewhere, all of it is running on decisions an electrical engineer made. This is their story. Before there were electrical engineers, there was just wonder. In 1831, a man named Michael Faraday moved a magnet through a coil of wire. And something unexpected happened. Electricity flowed. He didn't fully understand it, but he wrote it down. Decades later, James Clerk Maxwell took those notes and turned them into equations. 4 equations that described every electromagnetic phenomenon in the universe. Then came Edison. He didn't just invent the light bulb. He invented the system that powered it. Then came Tesla. And the argument that followed, AC or DC, whose electricity would power the world, was not a scientific debate. It was a war. A war fought with wires, patents, and public demonstrations. Tesla won the physics. Edison won the story. And the world got electricity either way. By 1884, the first professional society for electrical engineers was founded in New York. The AIEE. The world had decided, this is not a hobby. This is a profession. But nobody, not Faraday, not Maxwell, not Tesla, could have imagined what it would become. So what does an electrical engineer actually do today? The honest answer is, almost everything. There are electrical engineers designing the power grid that keeps your lights on. There are electrical engineers at Intel and TSMC designing chips so small that a single grain of sand contains more transistors than the chip that landed Apollo 11 on the moon. There are electrical engineers in hospitals building MRI machines that see inside your body without touching you. There are electrical engineers at SpaceX designing the avionics systems that guide rockets back to Earth and land them on a drone ship in the middle of the ocean. The field doesn't have one shape. There are electrical engineers who never touch a circuit board. They write the math that tells a power grid how to survive a lightning strike. There are electrical engineers who never leave a clean room. They spend years designing a chip the size of a thumbnail that will run inside 1 billion devices. There are electrical engineers in submarines, in operating rooms, in orbit. The title is the same. The work is everything. To become an electrical engineer, you typically need a 4-year degree. The first 2 years are brutal: calculus, differential equations, physics. You're building the mathematical language you'll need for everything that comes after. Then the specialization begins. Circuit analysis, electromagnetics, digital systems, microprocessors, control theory, After graduation, some go directly into industry. Others pursue a master's. Especially those aiming for chip design, aerospace, or research. Entry-level salary in the United States, around $70,000 to $80,000 a year. Senior engineers, $120,000 to $180,000. In Silicon Valley, total compensation for top engineers at Apple or Nvidia can exceed $500,000. But beyond the salary, there's something harder to measure, the device in someone's pocket. That just helped them navigate home safely. The machine keeping someone alive in the ICU tonight. The satellite that just transmitted this video to you. None of that happened by accident. Someone sat down, ran the numbers, made it work. That someone was an electrical engineer. We're entering a strange new era. Artificial intelligence needs hardware. And hardware needs electrical engineers. The GPU that runs a large language model contains 80 billion transistors. Each one placed with purpose. Each one consuming power that must be managed, heat that must be dissipated, signal integrity that must be maintained. Quantum computing is moving from theory to hardware. Someone has to build the dilution refrigerators that cool qubits to near absolute zero. Someone has to design the control electronics that talk to those qubits. That someone is an electrical engineer. The world is not running out of problems that needs solving with electricity. If anything, it's just getting started. This is the Profession Archive. Every week, one invention. One profession. The full story. If this video changed the way you see the world around you, subscribe. Because next week, we're going inside the chip itself. The microchip. An object smaller than your fingernail. That contains more engineering decisions than any building ever constructed. We'll see you there. The machine keeping someone alive in the ICU tonight. The satellite that just transmitted this video to you. None of that happened by accident. Someone sat down, ran the numbers, made it work. That someone was an electrical engineer.